Alright, today we're going to talk about ions, ionic, and covalent bonding. This is physical science standard 4C. So you guys are going to be able to describe the difference between ionic and covalent bonding. You're going to predict what kind of bonds will likely form when metals, nonmetals are chemically combined. So this comes back from our last unit when we had learned the periodic table with metals, nonmetals, and metalloids. So you need to know this. Alright, so real quick, I want to start out with this warm-up. Why is this joke not funny? So take a look at the two atoms and what they're saying. Okay, the first one says, I lost an electron. And the other one says, are you positive? So let's think about this for a moment. And if you remember from the last unit, we talked about the charges of an electron. And the charges of an electron were negative, right? And the charges of a proton were positive. So if you lost an electron from an atom, would you be more positive or more negative? Okay, if you're losing an electron, you're going to be more positive because we said the protons can never ever change. Alright, so that's kind of why the joke's not funny, or why this kind of seems like a little dull joke. Hey, so I want you guys to watch this video so you can be prepared for our next class where we're going to be working with our groups to complete an experiment. And we're going to actually do a borax and glue experiment and talk about bonding and how things chemically combine and they actually make new substances. So if you feel free to look at this video, the PowerPoint we posted on Vision. Okay? And then also I would like you guys to do on your own time is watch the brain pop on chemical bonding. Okay? So watch the brain pop with the link on Vision as well. So let's get started here. Let's review a little bit. So with your two-column notes or your Cornell notes. So you get a sheet. You can fill out this topic is chemical bonding on ions and ionic and covalent bonding. So the real quick review here is valence electrons. Okay, we talked about last unit. Valence electrons are the electrons in the outer shell. Okay, so we can take a look here. Oxygen has the first shell completely filled, but on the outer shell it has 1, 2, 3, 4, 5, 6. It has room for 2 more. So it has 6 valence electrons and room for 2 more. Over here, fluorine. Alright, we did this on a test, and on the outer shell it has 1, 2, 3, 4, 5, 6, 7. So it has 7 valence electrons. 1 is missing. So the first shell is filled, but the outer shell almost filled, not quite. Okay. Hey, we've also talked about this chart last class. So we're really not going to pay attention to the transition metals so much, like I said earlier. That's going to come up in high school chemistry. Well, let's take a look at the valence electrons in group 1. Group 1, all these elements in this group, up and down, have 1 valence electron. That's why they're most reactive. Group 2 has 2 valence electrons. Okay. Group 3, all the way over here, group 3, they have group 13, excuse me, has 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons, and so forth. Okay? And group 18 has 8 valence electrons, and they're the happiest because their outer shell is completely filled. When your outer shell is completely filled, there's no more room, so they're happy, they're stable. These atoms you find in nature all by themselves, never with a combination of other elements. So, another quick review. We talked about the first shell holds 2 electrons, and after the first shell, each shell needs 8 electrons to be full, stable, and happy. Okay, so the second and third can hold up to 8 each. Okay, we have this thing called the octet rule. Okay, and the octet rule says that atoms can give away or steal valence electrons in order to be happy and stable with a full valence shell. And this is the basis of bonding. Okay, so atoms with less than 4 valence electrons tend to lose electrons. We call them givers. If atoms have more than 4 valence electrons, they tend to gain electrons. We call them stealers. So if you have more than 4, you're going to take somebody else's electrons to be happy. Alright, so real quick, atoms give away or steal valence electrons in order to be stable or happy with a full valence shell. Remember, when an atom gains or loses electrons, it becomes a charge, and we call that an ion. So if you gain or lose electrons, I know this in the beginning we said balanced atoms have the same number of electrons as protons, but in bonding, electrons can be lost or gained. Okay? And when you lose or gain electrons, you form an ion. So here's a couple examples. Right? Two elements that have few extra electrons. Okay, what do they want to do? Okay, so we have sodium. It has one valence electron, one extra electron in that outer shell. Okay, so it wants to do what? So think about that. It's going to want to, it has 4 or less, so it's going to want to get rid of it. That's why it's so reactive. Sodium reacts with water. It's highly reactive, and it explodes because it's trying to bond and get rid of that electron. Magnesium is also reactive. If you remember from our lab, we put magnesium in acid and it was reacting. And that's because it has 2 valence electrons. It has 4 or less. It wants to get rid of them. It's a giver. Okay, it's trying to get rid of them. It's easier to get rid of those 2 electrons than to try to gain 6 more electrons. Right? So that's those are going to want to get rid of their electrons. The next one's here. Okay, 2 more examples. I want you to take a look. We have oxygen. Right? So remember, the shell, first shell is totally filled. Okay, second shell is missing 2. So do you think this is going to want to give away electrons or steal electrons? Well, it only needs 2 more, so it's easier for oxygen to steal electrons. Okay? Fluorine's the same way. It has 7 valence electrons. It needs 1 more, so all it needs to do is steal 1 electron from somebody else, so it can be very happy and very stable. Right? We have sodium, Na, who has an extra electron, and fluorine, who is looking for an electron. So, sodium, who wants to get rid of their electron, okay, wants to bond with fluorine, who needs an extra electron. So, sodium gives away its electron, and fluorine steals electron. And then they're very happy. Now, they're both very happy, and they're both very stable. All right, so here's another brain pop. This is all about ions and ionic bonding. So what I would like you guys to do now is we'll continue with our 2 column notes or your Cornell notes. And your question is here, what is an ion? So we talked about this. An ion is an atom who gives or steals electrons, has more or less electrons than protons. So an atom has a neutral charge because it has an equal number of electrons and protons. But an ion is a particle with a positive or negative charge. So an ion forms when an electron gains or loses electrons from its outer or valence shell. Right. Our next one is, how do ionic bonds form? So, take a look at the picture. The question is, how are the sodium and chlorine atoms held together in the compound sodium chloride? This is our table salt, the salt that you see at home every day or you put on your food. And what happens is it's an ionic bond for a couple of reasons. One, I'm going to move this over here. Right. One, because sodium has that 1 electron outside and wants to give away. And it gives away to chlorine. Chlorine needs 1 extra electron to be happy. So now we have sodium chloride, or salt, NaCl. Okay? Sodium becomes a positive ion because it gave away a negative electron, so now it has more protons than electrons. And chlorine stole an electron, so now it's a negative ion because it has 1 more electron than it has number of protons. So it has more negative than it has positive. So an ionic bond is a force that brings oppositely charged ions together. Okay? Ionic bonds formed when electrons are transferred from a metal, very important, from a metal to a nonmetal. So ionic bonds only happen from metals to nonmetals. In the process of ionic bonding, valence electrons move from the outer shell of the metal to the outer shell of the nonmetal. Okay. Covalent bonding is a little bit different. Covalent bonding, instead of stealing, they like to share electrons. Okay? So they share 1 or more pairs of electrons. So when two nonmetal atoms bond, a large amount of energy is needed for either atom to lose or gain electrons. So they bond by sharing those electrons. So O2 is sharing 2 electrons. Sometimes they go around the oxygen, sometimes they are around the other oxygen. So in a covalent bond, the shared electrons fill empty spaces in the outermost electron shell of each atom. Now, what's a molecule? Okay, a molecule, okay, is just two or more elements combined, but it's only one. It's the smallest part without without breaking it apart. So we can have a molecule of water here, and this is a covalent bond because it's sharing electrons. The hydrogen are sharing electrons with the oxygen. And I can't get any smaller than this because if I did, it'd break apart and it wouldn't be water anymore. So substances have a covalent bonds are made of individual particles called molecules. A molecule is a group of atoms held together by chemical bonds. Right? A molecule is the smallest unit of a compound that can still be identified as that compound. That means if you tear off one of these hydrogens, or if they would go away, it would no longer be water. Okay? It needs to have two hydrogens and one oxygen. All right, so here's a quick YouTube video I would also like you guys to watch. So you can go on YouTube, type that in, or you can click on the link. And, real quick, ionic or covalent. If you look at it, carbon and oxygen, they're both nonmetals, so they're going to be covalent. Nonmetal and a nonmetal is covalent. Bromine and iodine. If you look on the periodic table, bromine is a nonmetal, iodine is also a nonmetal. That is a covalent bond. Okay. Magnesium and oxygen. Well, magnesium is a metal and oxygen is a nonmetal, so that is an ionic bond. Okay. It's just that simple. Okay. Calcium and chlorine. Calcium is a metal. Okay. Chlorine is a nonmetal, so it's an ionic bond. Right. And one more. Lithium and fluorine. Lithium is a metal. Fluorine is a nonmetal. This is an ionic bond. Okay. When you come back, you'll be working in your gizmo on ionic and covalent bonding. And then we'll also do a lab as a class. We're going to build some models of ionic and covalent bonding. Thanks again. All right. Bye.